Hello, Python coders. Welcome to Chapter 9, Dictionaries, our final chapter that we are responsible for in this course. A very interesting chapter, by the way. But just before we get started on that, I wanted to discuss a couple of things with you. We are now in the countdown to the finish of our course. As I'm sure you're aware, I'm going to bring up a calendar here. We're on the 29th of November right now. And our course supposedly finishes on the 10th of December. But in fact, we can't go that long. That's actually when I have to hand the grades in on that date. So I would like you to get all of your work into me by December 8. Okay, so consider December 8 as the last day for submitting assignments. You can redo assignments that you didn't get full points on. Okay, you can go back and do any assignment that you didn't get full points on, but don't give me a bunch of assignments in the final week of the course, okay? So try to do them this week, okay? If you're gonna do some redos to get more points, I invite you to do so, but please do it this week so I have time to get them graded to give you the credit that you deserve for the course. But if you submit them all late next week, I just won't have time to get them done. Okay, so hang in there and keep on working away. I think if you check your grade books, if you've kept up with your assignments, you're probably in a passing situation now. You should have enough grade points at this point if you've been keeping up with all your assignments to be in a passing situation, but you might just have a C or D grade. But if you keep going, and I guess today what's due is the number systems test, I think is actually due today. Get that done and try to get your full points there by showing a method when you do the test. Don't just put the answer in or you only get half points. So get as many points as you can there and try to get a good grade on this dictionaries chapter that we're going to start learning about here right now, and you'll end up with a good grade. All right, so let's get into chapter 9, dictionaries. We're not going to cover sets, by the way. We're only going to cover section 9.1. So we're not doing sets, we're not doing serializing objects, just dictionaries in this chapter. So what the heck is a dictionary? Well, it's a data structure that stores multiple pieces of information, just like a list in that respect. Lists that we covered in chapter 7 stored collections of data, but dictionaries are a little bit different in that instead of being able to access each element in the dictionary with a number like we can with a list, right? Remember how lists work? They're indexed starting at 0. Well, the way a dictionary works is it's a key value pair type of structure. You have keys and values, but the keys aren't numbers. The keys can be different things. They can be strings or numbers, but the whole thing is it's a key and a value structure. So you'll be looking up individual values, not with an index, but with a key. And the key, when you create the dictionary, you can specify what the keys are. So it's a very useful data structure. Just as an example where you might want to use a dictionary, if you were thinking about employees in a company, well, every employee in a company has a particular job title, right? Well, a job title could be a key. The person who does that job, that would be the value. So if you wanted to look up who's the safety supervisor, you could look that up and you would see that's Homer Simpson. Apparently, that's Homer's job. And that would work the same way for other dictionaries as well. Another example of a dictionary might be, say, a baseball team. Baseball team, the key might be the position that the player is playing, and the value might be that player's name. So key pitcher, value whatever. Okay. So let's carry on. I'm going to go, basically what I'm going to do here is I'm going to go through this chapter, and we'll try some examples, of course, as we encounter the need to do so. Now, how do you create a dictionary? Well, here's an example right here of how you could create a dictionary called phone book to keep track of the names of people that you know and their telephone numbers. Let's try making one. Let's try making our own. So I'm going to fire up an idle window here. And we're going to make a dictionary just in the interactive mode here. We'll create a dictionary. And I won't make it the phone book one. Let's say we're going to make up one for let's see, what could we do? How about team? Now, when you make a dictionary, you use curly braces, not square brackets. That's what lets you know that you're working with the dictionary, when you see the curly braces. As you know, with a list, it was square brackets. Now, inside, you have key value pairs. So I'm thinking baseball here. Okay, so let's say we go with pitcher as the key, and the actual pitcher is going to be, I wish we didn't get rid of this guy, Morton. That's probably why we didn't get to the World Series. We lost Charlie Morton. And so there's a key value pair, and we separate them with a colon. So key is pitcher, value is Morton. Now let's look at another player's name. Let's go with 2B for second base as the key. And who's playing second base? Well, it varies in our case. I guess we could put, who could we put in there? Maybe we could put Wendell in there. Okay, so he's playing second base. Shortstop, who's playing shortstop? There's another player I wish we didn't get rid of. Was Adames. We got rid of him, unfortunately. So there is a very small dictionary with 3 elements. We've got 3 elements, 3 keys and 3 values, separated by the commas. So that's how you can create a dictionary. Now, how do you access one of the elements, one of the values in a dictionary? You do it by its key. So if, for example, I entered team, and then in curly braces, or sorry, not curly braces, inside square brackets, and that's, you might think, well, why wouldn't you use curly braces? But it's back to square brackets to specify a particular key. So I'll put the key in here of second base, and that will give us Wendell. So get the idea? You have key value, separated by colons. When you create the dictionary, each individual element, which is the key value pair, you separate with commas. And when you want to retrieve a particular value, you do it by its key inside square brackets. Okay. You can add elements to the team in the same way. I could go with team, specify square brackets, and put a new key in. So let's say we want to put in center fielder, and specify that as Kiermaier. We've just added to the team. We've just added to the dictionary. So this is how you retrieve an element out of the dictionary. And this is how you specify a new element. If I just enter team alone, it'll just dump the entire dictionary onto the screen. It's like printing the team. And you can see that Kiermaier was in fact added to the dictionary. So that's just some basics of how you would work with a dictionary.
And that would always be printed at the end of the list?
When you do this, that's right. That's right. Yeah, they're added at the end. Now, a really good way to go through a dictionary is to use a loop, a for loop. As you might expect, we can loop through a dictionary very nicely with the for loop. As an example, we could try for K in team, print, and I'll go with an F string. And I'll put here as the first placeholder, I'll specify K. And in this second placeholder, I'll put K square bracket, square brackets, and the particular, this one would be this one has to be the name of the dictionary, team, and then the K goes in the square brackets. So let's see what that does for us. Okay. So when we say for K in team, we're referring to the key. K is short form for key. By the way, you don't have to use K. You could use the word key if you wanted to. You could say position, POS, which would be relevant, I suppose, when we're talking about a baseball team. But you have to have some variable here, and that'll be the key. For K in team, print the key, and then the value that's in the dictionary that has that key. That's what team K gives us here. And that's what we're going to see in the next few pages of our textbook here. So let's look on at the next page or so. Yeah, they're actually showing you some of the stuff that we've already tried. If you enter, in this case, with the phone book that they've created, the phone book dictionary, and you can see they've got names and phone numbers as values, names as keys, phone numbers as values. If you try to access a particular key that's not in the dictionary, you get a key error, as you can see down here. Okay with that? Any question about anything so far? Don't want to go too quickly. Get the idea here. Curly braces. You have to have two parts to everything you add to a dictionary. You have to have a key and a value, and you separate them with a colon. To add other elements to the dictionary, go with a comma and another key value pair. So think of pairs, key value pair, key colon value, key colon value. That's the way it works. To retrieve an element, you can do it by specifying inside square brackets the key of the value that you want to retrieve. You can add another element to the dictionary by specifying a key and assigning it a value. So I hope you're okay with that. Now, next thing you'll see here in the textbook is using the in and not in operator. You might recall that we use those with lists as well, right? If we wanted to see if a particular value was in the list, we could use the in operator, which would return true if that value was in the list. Well, we can use the in and not in operators with dictionaries as well. When we do, though, what we're doing is we're testing to see if a key is present. So when you're using in and not in with dictionary, we're thinking about the keys. So we could, for example, check that in that example that we were just looking at. I could type in, for example, SS in team, and that returns true because we do have a shortstop in the team. Now, normally that's not the way you use the in or not in operator. Normally you're going to use that in an if decision, right? So you're going to normally use it like this. If, and we'll try a different position here. If CF in team, the name of the dictionary, if the center fielder is on the roster, then we'll print that out. What we could do is we could use an F string. We could say, yes. And we could say, team. How could we say it? We could say, team. This would have to be a placeholder. In a placeholder, we could say team square bracket center fielder. Now, because I have to quote this, I'm going to have to use double quotes here. So let's see if that works out okay. I didn't put, I forgot my placeholder. I forgot my placeholder right here. We'll get this to work. We'll try this again. What I forgot was the closing curly brace right here. Oh, what's wrong there?
Yeah, you didn't put the parentheses at the end.
Exactly.
Mm-hmm.
Exactly. So I had two errors. Well, no, I did have it. I did have it at the end. What the heck is going on here?
You still have the squiggly brackets after CF.
I do need that for the placeholder.
But there's none starting.
Yeah.
Because you had the
no,
one for team and then you ended it after the CF. And then there's none after.
Honestly, oh, I shouldn't have this one. That's the one that's got to go. I got to resize this window here. So I can scroll down here. This one here is wrong. And it's actually highlighting it quite nicely for me. So that's the one we got to get rid of. This one right here. There it is. Whew, that was embarrassing, but it did work. It did work finally. We could have done this with a couple of different steps, right? I was trying to knock it all off with one line here. Probably what you should do in a case like this is do the assignment of who's playing center field first, so that you can just put a single variable in here instead of it's rather complex to put this inside the placeholder, right? And when you introduce that complexity, it's pretty easy to make mistakes like I did there, unfortunately. But I hope you get the idea of the in operator. It checks to see if a particular key is in the list or not. And you can use not in as well. So let's try using not in. Let's try using not in. So we'll go with if, and what we'll do is we'll make sure that we try some position that is not in. So we'll go with if LF not in team, which it's not, right? So that will return true because it's not in the team. So what we'll do is we'll try to add the center fielder. So we'll go with team left fielder, I should say. Team LF equals, we're going to add him. And this would be Arozarena, Rookie of the Year. Okay, so that just added Arozarena because we detected that he wasn't on the team by using the not in operator, and then we added him to the team. So let's see what's on the team now. And there he is. Arozarena has been added. So you've got not in and in operators, which are very useful to work with a dictionary. Let's see what's coming up next here. Adding elements. Well, I guess we've already done that. In fact, we just added Arozarena. It's pretty easy to add elements to a dictionary. Can't have duplicate keys. Here's a really important point. Cannot have duplicate keys in a dictionary. That would be counterintuitive to the whole concept of what a dictionary is. Every element in a dictionary has to have its own key. So you can't have duplicate keys. That would just not make sense. Now, how do you delete an element? Well, we can do that. We can do that with the del keyword. This is not a function though. It's just del, name of the dictionary, and then you can specify the key that you want to remove. So it's not a function because there's no parentheses here, right? You can see there's no parentheses in the example that's shown here. So we'll go back and try one more piece of code here. Let's say that we want to substitute our pitcher. We want to change the pitcher. So Morton is going to be substituted. So what we'll do is we will delete him. We'll del team, and then we'll specify what key we want to get rid of, which is pitcher. So that should get rid of Morton. Let's verify that by looking at the team again. Yeah, he's gone. Morton's gone. Now, of course, we'd have to add another pitcher to carry on with the game, get our reliever in, but it's just that easy to remove a particular key. Just use the del keyword and specify the key. Now, one mistake that it's really easy to make is make sure you put the key has to be inside quotes, right? Because that's the way we set this dictionary up. But not all dictionaries have to have strings for the keys. We can have numbers for the keys as well. So I'd like to show you another example here. I think the next thing that's coming up is, well, the number of elements in a dictionary. Okay, so what we can do here is, let's look at another example that I've got prepared for this. And we've got one here called Dix. Here it is. And this one is along the lines of the federal government. Branches of the government, as you know. You've got the executive branch, which consists of the president. And I guess it's the office of the president, all the people that work for the president. It's not just the president himself. Then you've got the legislative branch, which is Congress. And then you've got the judicial branch, which of course is the Supreme Court. So those are the branches of the US government, as I'm sure you know. Now, we could go through that with the for loop, for K in branches, print the key, that's going to be each individual key will show up there. And then here we've got branches K, which should print out each of the values. But a dictionary is a special type of animal in Python. It's an object. And just like a list was an object. And we learned that lists have methods, right? Lists have methods. Don't let that word method throw you off. A method is just a function that belongs to an object. It's the same thing as a function, but it's owned by an object. Well, dictionaries have methods too. And one of the ones that's extremely important and useful is the items method, the items method. So what we're going to do is show you another way that we could go through this dictionary called branches. We could go with for K, V in branches.items. Now, looks kind of weird to see two numbers here, or two variables here, but it's for the key and the value. For key, value in branches.items, let's print out the value first and then the key here. It gives us great flexibility. The syntax is a little simpler. We don't have to have a complex expression inside of a placeholder. We can simply have K and V inside of our placeholders. Much easier. So let's see what we get when we run this one here. Here's the output that generates. Okay. So as you can see, we got slightly different output because we specified different strings inside of our print statement. But you can see here we got the value for each of the elements. And then here's the key, the second part of the output. Now, I personally like this items method better. I think it's easier for the print statement that you might want to use. However, this is useful too. Like maybe you only want to print the keys. If you only wanted to print the keys, you could just, get rid of this part of the string to print just the keys themselves. There's another way to get the keys though, as we shall see. So this is an example of two ways that we can go through a dictionary with a for loop. We could use just the key here, or K, V, which along with the items method gives us a little bit easier code when we go to create the string, the output string in the print statement. Now, we brought this up because we got to getting the number of elements in a dictionary. So let's see if we can make use of that here. If we add a line, we should be able to do it. I'll throw it in right here. We can say size equals len of our dictionary. The len function. We've seen it before. in other situations, in the case of a list, it tells us how many elements were in the list. Well, the len function also tells us how many elements are in a dictionary. And then we could print that out. So we could say print, use an F string. We always want to try and use an F strings. And we could say there are size, put our variable inside the placeholder. Okay, so that should print out now. So I'll just run it again to see how that runs. And here's our output, which of course is correct. So you got the len function to determine how many elements are in the dictionary. Any question about anything so far, folks? No? Okay. Well, I want to show you another example. Got another one that we can show you. This one is actually a baseball one. It has a baseball theme, but it's a little different because what we want to show you in this example is that you don't have to have strings as your keys. Check it out. We've got a lineup for a baseball team. Lineup shows the batting order, who's batting first, etc. on a baseball team. Well, we can use numbers, integers, as keys. Notice key, colon, value. So the value is the name of the player, and the key is an integer in each case, which represents the batting order. And we can go through this lineup. Once again, we can use this approach like we did in the last example, or we could use the lineup.items method. And this time, instead of KV, I'm actually using bats and player because that's really what our dictionary is all about. Now, I certainly could have used KV here. Most of the time I am going to use KV actually when I do this personally, but because we are talking about batting order and player names in this particular dictionary, it makes sense to use those names. So let's see what this one runs like. We're just trying to demonstrate here that you don't have to have strings for your keys. The strings could be numbers. They could be floats in some cases if you wish. In this case, they're integers. So when we run this one, we get the same output two different ways. As you can see, it shows our lineup. Any question about that one? Keys can be numbers. Get great flexibility when you're creating a dictionary. If you wanted to reassign one of the, you want to put a pinch hitter in, for example, maybe Wong isn't hitting as well as he should be, and maybe the pitcher that's facing him is not good for his batting style. Well, you could replace him just by specifying it, changing that as we saw before. No questions? No questions? We'll just carry on then. Next thing that comes up in this chapter, mixing data types. Now this is pretty interesting. Here we've got something new. Take a look at this first dictionary as illustrated by lines 1 through 4 here. What we've got here are names as keys, and following each name, of course, we've got a colon, but look what's after each name. It's not just a single variable, it's a list. So in this case, what we have is a dictionary in which the keys are names and the values are lists. And apparently they're lists of test scores in this particular case. Okay. Now I've got an example kind of like that one. Let's see if we can take a look at one like that. And here it is. I'm going to create a dictionary of states with abbreviations, state name abbreviations as the keys, and lists as the value for each key. Each list contains the full state name as well as the capital city for that state. So let's take a look at it here. The name of our dictionary is states. And as you can see, we've got state abbreviations followed by a colon. And then for the value for each abbreviation, we have a list which has the full state name followed by the capital city of that state. And of course, I didn't do all 50 here, of course, but as you can see, this stores that information. So this is not unusual that you have a list as the values. Now, it does complicate a little bit how you access these values that are in the list. Remember that the values in a list are accessed by their index number, right? And the first element inside of a list is index 0. The next one is index 1, right? So this would be index 0 of the list. This would be index 1 of the list. So that being the case, if we want to use a loop to go through this dictionary, it would go something like this. For K in states, print inside the first placeholder here, I've got the name of the dictionary, the key, and I've got a 1 here. So that should actually print out the name of the capital city of each state. There's the name of the dictionary, there's the key, and following that with another set of square brackets for the list, that's going to grab Sacramento for the first element. And if we look at our second placeholder here, we've got, again, states K, but now we've got a 0 here. So that's going to show the name of the state, right? That'll be the full state name. So that'll be California for the first one, for our first element. And then this is going to actually just show the key. So that'll actually show the abbreviation, which is the key. Now we can do the same thing with the items method, which actually turns out as before to be a little less complex. Instead of having this kind of complex expression here, we simply can have V0, where K comma V, remember K comma V means key comma value. So the V, that captures the entire list. The list becomes V. So V0 is going to be California, for example, and V1 here is going to be Sacramento for the first element in the dictionary. So let's see what this looks like when we run it. This is about the trickiest thing that we have to do in this chapter, by the way. But let's see what happens when we run this one. Here's the output that I got, and we're doing the same output, but 2 different ways. Well, actually, the output's a little different, but can you see why we get the output that we do? Can you see why we got this for Maryland? The first thing we're printing out is K1, which means the second element here in the list for MD, for key MD. And we got Maryland here because we were after the name of the state. So this is your V0. Okay. We could add another element to the dictionary. Let's add another state. All we have to do to get that done is go with states, specify a key. In this case, the key is supposed to be the abbreviation for the state. What state would you like to add? Anybody? Pick a state.
The state of Virginia.
Okay. What's the abbreviation for that?
VA, I think.
I think it is
Or,
VA. I think it
no,
is VA.
sorry, VI.
It's VI?
Hang on.
I think it might be VA. Anybody else want to verify that? Is it VA? I don't think there's I don't recall ever seeing a VI. And of course, there is only one.
Yeah. Sorry, I was right before VA.
Okay, VA is good. All right. So VA equals, now we have to specify a list, right? Remember, the values for this dictionary, each value is a list. So we have to have the state name followed by the capital. So this would be Virginia, of course, for the state name. And the capital of Virginia, what the heck is the capital of Virginia?
Richmond.
Richmond.
Richmond, very good. Okay, that should add Richmond to the, or I should say that should add Virginia to our dictionary. Let's check it out. So I'll run it again. And there it is. Once again, we ran off the screen a little bit, but it did work okay. Okay, I hope you're all right with that. So it's a little bit complex, but if you look at it carefully, it does make sense. Remember, when you're working with a list, each element in a list is indexed starting from 0. So this is going to be index 0 in the list. This will be index 1 in the list. So that's why we have a V0 here when we wanted to output the name of the state, which is what we did in the output here, right? California is the name of the state. That's V0 inside the list. This is just the short form. That's the abbreviation for the state. That's our key. And here, V1, that's the capital of the state because it's the second one in the list, which is V1. You got to keep in mind that lists are indexed starting from 0, not 1. Okay, so that's the objective. So how are we going to do this? Well, to start with, we need to start with an empty dictionary. We'll start with an empty dictionary, and then we'll use keyboard input to prompt the user to enter the keys, the values, the prices, and the quantities. So I guess we could call it inventory. Makes pretty good sense. That's going to be the name of our dictionary, inventory. And it's going to be an empty dictionary. So empty set of curly braces. Okay, there's an empty dictionary. And I want that to be a comment. Okay, so there's our empty dictionary. So now what we'll do is we'll prompt the user to enter the inventory item. And we'll call it item. Item equals, and we'll go with input, of course, to get input from the keyboard. And our prompt will be enter item name. Okay, and we'll keep this up. We're going to start a while loop now because we're not sure how many items we're going to add to our inventory. So whenever you're not sure how many times the loop is going to have to execute, you want to use a while loop. So let's go with while here. While item does not equal an empty string. So actually I should modify this to say, or enter to quit, because that's what will cause the loop to stop. When the user presses enter alone, then the item will be an empty string and that'll stop our loop. So our loop will continue while it's not an empty string. And then the next thing we want to do is we want to prompt the user for the price and the quantity. So we'll do that. Price equals, now that price is, of course, is a float, isn't it? So it would be price equals float, input, enter price of item. Hey, do you want to do something kind of cool here? Like notice here I'm being not specific, just price of item. What if you wanted to say you actually wanted to use this value that we already know, like we already know what the item is. We could put the item name right here instead of just being generic and saying an item. And we could do that if you want. We'll show you how to do that in a moment after we get this done. So let's get the quantity next. I'm just going to call it QTY, and that's going to be an integer. And then we'll prompt the user to enter the quantity of the item. Okay, so now we've got everything we need to know about that particular item of our inventory. So now we should be able to add this item to the dictionary. So we know how that goes. You go with the name of the dictionary, and then inside square brackets, you specify the key. Well, that's going to be our item, but yeah, I guess that's not a problem. So we need to put that inside quotes because it's a string, right? So, but just we actually don't need the quotes. We don't need the quotes. It'll be the item variable, that we're going to put in there. And now we know that we're going to use a list for the price and the quantity. So we'll just put our price here and our quantity here. So that should add to the inventory. Now, before we go any further, let's make sure that this is working by adding, of course, we're going to add more items. So what we'll do is we'll repeat this line. I'll copy it and paste it as the final line inside the loop. But that's not in the loop, so I have to tab it in once more. So now it's inside the loop. So this should allow us to add items to our inventory. But I want to make sure that this is working properly before I go any further and start processing it. So what I'm going to do is I just want to print it out. We'll just dump it out onto the screen. We'll just go with print inventory. Okay, so that's just a test to see if this thing is working. And then we'll add more code in a moment if this works okay. Now I don't want to call it dix3, so I'm not going to run it. I don't want to overwrite that program. So I want to save this file, save as. I will save it in this same folder where I've got all these files I'm going to send to you, and I'm going to call this one inventory, obviously. Inventory. Okay, and now I'm going to try to run it. So let's see what happens when we run this thing. Here we go. And here's my output. Okay, so I'm thinking that I'm selling clothing. So I'm going to go with shorts. And these shorts are $12.99. And I've got 6 of them in stock. Now here we go to the second item. Okay. Shirts. These are $14.95 a piece. And I got 10 of those in stock. And then we'll go with socks. And these are $7.99 a piece. And I've got 12 of them in stock. And maybe that's enough just to see if what we've got is working properly. So I'm just going to press enter here. Yeah, there's the dictionary. So the dictionary did get created. And it looks like it's been created properly. As you can see, the key is the item name. And then we got the colon. Remember, the colon separates your keys from your values. The value in each case here is a list with the price and the quantity. So this is what I had hoped would happen, and it did. So now we can carry on and do this again. Unfortunately, we'll have to enter those items again when we run this. But I suppose we could have written them to a file. That would have been a cool thing to do. And then we could read them from the file, but we still have to read them anyway. So, okay, so now that we know that that works, I'm going to get rid of this line. So we were able to create our inventory properly. So now let's process it. And I'm thinking, let's use the items method to go through it with a for loop. Let's go through our inventory with a for loop. And what we'll do is we'll work out the inventory value of each item by multiplying the price times the quantity, right? So let's do that with the for loop. So that would be for K, comma, V in inventory dot items. This items method is the way to go, I think, because it'll make our output much easier. Now, what we want to do, we don't have to process the key at all. That's just a string, but we do have to analyze the V, the value, which is our list. We've got to multiply the two numbers together that are in the list. So I guess what we could say there would be value equals. Now, how am I going to multiply those two together? What do I have to multiply to get the value here?
Price times quantity?
That's right, price times quantity. But now how do I refer to the price? How do I refer to the price? Using thinking about what we've got here, right? Thinking about the list here. Remember, our lists are, that's the V back here in our program. V is the list.
So the price, would it be V times what would be the quantity?
It's V something. And this one is also V something. But we need something after the V in both cases. We need the index, right? We need the index of these items in the list. See, this is the V in each case. So how do we refer to the $12.99? That's
0?
Exactly, good for you. V0. And how do we refer to the quantity?
1.
That's a 1, right?
Mhm.
Okay, so that's all we need to do. That should multiply those two values together for each item. Okay. Now, if we want to print that out now, we should be able to print that out with an F string. So we'll go to our F string. Now, what we want to print out is, let's say we want the item name first, right? So that's our K, right? So we'll put that inside of a placeholder. And then I'll put a comma in. Now I want to get, I'm going to try to put the quantity. I want to output the quantity first. So that would be V1, right? So I'll put the V1 inside that first placeholder. And then I'll use an @ sign. And the second placeholder is going to be the V0, where the price is. Now, I guess we could put a $sign here because it's going to be the price. And I suppose we could format this with 2 decimal places, right? So we could do like 0.2F on this one. You know what I'm thinking? Notice that we're getting some real complexity inside of our placeholder here. Maybe a better idea would be to convert these into variables that mean something to us instead of V0 and V1. So maybe a good approach would be something like this. We could say price equals V0. And on the next line, we could say quantity equals V1. And then for our value, we could use the more familiar terms, price times quantity. Maybe it's less confusing this way. Okay, and the advantage of this is that in this placeholder here, we can put our QTY variable, and in this one, we can put our price. And format it with 2 decimal places. And then we still want to get the total value of this item as our final. So we'll put our value variable inside the last placeholder, and we'll format it with 2 decimal places as well. So that would be 0.2F. So let's see if this works. Okay, let's see if this works before we go any further. I think we've got it right, but as we saw earlier, I don't always get my programs right first time every time. Let's give it a try. Unfortunately, I do have to enter everything again every time I run this, so let's give it a shot. So here we go. So we'll go with shorts again. I forget what I've entered for the price. Let's say they're $14.99 and I've got 6. Then I'll go with shirts. They're nicer shirts, $29.99, and I've got 10 of those. Socks are $7.99, and I got 12 pairs of socks for sale. And we'll stop it right there just to see if what we've got is working properly. Yeah, I'm liking it. It looks pretty good. Shorts 6 at $14.99, value $89.94. So it looks like it's doing the math properly. So I'm fairly happy with the way this is running. Do you follow what's happening here, folks? You get this V0, V1 part. That I think is the tricky part. Remember what we're doing with that V1 and V0 is we're reading the value in the right here. We're getting there's V0 and there's V1. And we're multiplying those together to get the value of that particular item. Now, if we wanted to get the total value of all of our inventory, we would have to have an accumulator variable in here to add up all of these values, right? And to do that, you always have to specify the value of your accumulator as 0 before you start your loop. So you could say like total equals 0. I'll put a comment on this. This is our accumulator. And what we'll do is after we've found the value, I guess that would be the most logical place to do the accumulation. Right here, we could say total plus equals value. And then after we've printed out all of the inventory values of each individual item, after the loop finishes, we backspace to print out the total inventory value. Once again with an F string. So we could say total value of inventory is, and again, we go to our $, our placeholder. And we're going to put total here. And we're going to format it with 2 decimal places. Now, I suppose it's possible that maybe we're selling cars or something. We could put a comma in here for thousands, right? Or maybe we're selling really high-end fashions that are extremely expensive. So we get into thousands of dollars. So we could put a comma in there to handle the thousands. So I think this is not bad. Now, maybe before we start printing, the results of the inventory here, probably not a bad idea to put some sort of a heading in here. So I think I will add right here, after we finished adding the inventory items, we'll put a print statement in here. And we'll just make it, this will just be an ordinary print statement. And we'll start it with a /n to separate it from the rest of the output here. Here is your inventory. We'll just output something like that. Just to separate so that we have a blank line after this line, before this line. So can you see how really valuable dictionaries can be? Particularly if you have values that happen to be a list, then we can do some really powerful things with dictionaries. But it takes a little getting used to. This part here is very important. The K is the key, the V is the value. But in our case, the value is a list of 2 items, price and quantity. So I guess this program is finished now, so I'm going to send it to you. I think it's going to work okay, so I'm confident that I can send it to you right now. And this is called inventory.
Wait,
Oh, okay. You wanted to add something to it?
you had forgotten to put the variable name inside of the float, where it has the float input enter price of item. You're going to actually state the name.
Oh yeah, right. That's right. Thank you very much. Yes, I did forget about that. We want, instead of just being generic here and saying item, let's actually see if we can put the name of the item in there. Well, we should be able to do it because all we need to do is make this an F string. We can put F strings inside of our inputs too. Whenever a string is needed, you could always make it an F string. So all we need to do is put an F here. And right here, we could put, as it happens, item is the name of our variable. So we could just do it like that. I think that should work okay. And we could do it here, of course, with for the quantity too. F, quantity of item. Yeah, thank you for reminding me about that. Yeah, great. So I did want to show you that you can use F strings in your inputs as well. So let's give it a try, but I'll send it to you first because I do think it's going to work. So it's coming to you right now in the chat. You can try it on your end and you don't have to enter the same values as I am going to, but I'm going to try it again here. You can follow along if you wish. So here we go. And maybe I'm going to sell something else here. Maybe I'm a fruit stand at the flea market. I'm going to sell fruit here. Okay, so I got bananas. And bananas, I'm selling them each banana. I'm not selling them by the pound. I'm selling them by the bunch. Okay, and a bunch of bananas is $1.99. And I've got 12 bunches. Okay, I've got apples. And I'm selling them by the bag of apples. So $3.99. And I've got 8 bags. And I'm going to sell watermelons. And watermelons are $4.99. And I've got 6 of those in stock. And let's see, I could also sell oranges. And I'm selling these by the bag, and they're $5.99 for a bag. And I've got 15 bags of those on hand. And let's see, what else could we sell for fruit here? About strawberries. So we've got strawberries, and we're selling those in little containers that are $3.99 a piece. And oh, I forgot to put the S on strawberries, but that shouldn't matter too much. I got 20 boxes. All right, so let's say that's the end of it. So there it is. Worked great for me. I assume that's added up properly. Pretty cool little program using dictionaries. Dictionaries are very, very powerful ways of working with your data in a computer program in Python. Other languages also have something like a dictionary, by the way. C# language, they call them dictionaries in C#. What works the same way as a dictionary in Java is called a map. It's called a map in Java. In some other languages, they're called associative arrays, like for example, in PHP or Perl. But every programming language has a dictionary type of structure that you can use. Okay, so I hope you're all right with that. Any questions about this one? Well, thanks for hanging in there during the interminable noise that we had to go through. Let's take a look at a few more examples here. Let's take a look at a few more examples. I've got another one. But just before we leave this, any questions about it? Okay. Actually, let's see what's coming up in the textbook. I think we've kind of covered what's going to be coming up here. Yeah, create an empty dictionary, just an empty set of curly braces. That's what we did for starters. Using a for loop to iterate over a dictionary. Well, we've done that. For sure, we've done that. And we've also done it with the items method. Now here's some of the other methods. Let's take a look at this. This is on page 475 in your textbook. And you can see we've got a table here of some dictionary methods. We've got a clear method, which clears the contents of the dictionary. Doesn't actually erase the dictionary, it just clears the elements that are in it. So you end up with an empty dictionary after running the clear method. Get, oh, this is an interesting one that we haven't actually tried yet, but it's another way that we can retrieve a particular value by its key. We use the get method and put the key name inside the parentheses, and we can retrieve a value that way. There's that items method that we've used so successfully in that last program. There's a keys method that gives you all the keys as a sequence of tuples. Now, we didn't cover tuples in chapter 7, but you can basically think of it as like a list, really, because a tuple is like a list, except that it's immutable. You can't change it. Pop removes a key value pair from the dictionary. So that's another way you can delete something from the dictionary is pop. But it also returns the value at the same time as it pops it out of the dictionary. Pop item also deletes a value out of the dictionary, but it gives you the key and the value, not just the value. And finally, there's a values method, which returns just the values alone. We could try, actually got a sample program, which shows you some of this. Let's take a look at it here. Here's another program that uses dictionaries and does demonstrate some of those methods that you see on page 475 in your textbook. Okay, this time, now I'm doing something here that's not in our course, but it's kind of interesting, and it does kind of follow up a little bit from what we did in chapter 8, where we talked about number systems. And you might remember at that time, we did talk about ASCII characters that are associated with numbers. Well, the CHR function will tell you what character exists for a particular value. So what we're going to do here is we're going to create a dictionary comprehension. This is a dictionary comprehension right here. Remember that we had list comprehensions when we covered lists in chapter 7. Well, you can make dictionary comprehensions too. You start off with your set of curly braces, and you can actually put code inside the curly braces to make a dictionary. Now, when you do that, you have to use dictionary-like syntax. You have to use key, colon, value. So in this case, our keys are going to be CH, and our values are going to be the ASCII character for that particular value. And then we're going to use a loop. We're going to go through the values from 97 to 102, which happens to be the lowercase alphabet values in ASCII. I think we're going to see the lowercase alphabet starts at 97 in ASCII. So then we're just going to dump that out onto the screen here. So let's see what that does. Now, what I'll do is just to uncomplicate this a little bit, I'll comment this out temporarily. So we'll comment that region out. So we're just going to run this much code here. Let's see what we get. We get from 97 to 102. We don't get the entire lowercase alphabet. We get from 97 to 101, because remember, that's how the range works. You don't get the last number, right? It stops at 101. But as you can see, we do have for each number as key, the value is the ASCII character associated with that number in the ASCII coding system, A, B, C, D, E. Okay. Now, what I'm going to do is I want to test a couple other of those methods So I'm going to copy that. I hope that copied it. And I'm just going to call this, we'll call it ASCII. And see if I can paste it in. Yes, great. Okay, so I just wanted to quickly make that dictionary interactively here. So that should make that dictionary. Now, I want to show you what you get if you use the keys method. So if I try ASCII dot keys, it gives me just the keys, as you can see, from 97 up to 101. If I were to try the ASCII dot values method, I get just the values, A, B, C, D, and E. Okay, now you're rarely going to need those, but you can access them if you need them. So those two of the methods that are shown here, keys and values. Maybe we'll demonstrate clear as well. Let's see if we can demonstrate clear. We should be able to. So if we type in ASCII dot clear, now it's an empty dictionary. Let's see what's in ASCII now. An empty dictionary. Didn't delete the dictionary. Okay, to delete the dictionary, you actually use the DEL key and the name of the dictionary that you want to get rid of. Now, I'll get an error message when I type in ASCII. Oh, actually, I didn't. That's interesting. There's actually a built-in function. I guess we should have known that when it showed up as purple, right? It's a built-in function. But our dictionary called ASCII is gone. Okay, now that was part of the output of that program. Let's look at the rest of that program because there's some other stuff in there that we can look at. So what I'll do is I'll uncomment a little bit more of it here. I'll bring back this part here by selecting uncomment the region. So now we'll just concentrate on this much code. So we'll see this first one again, but now we're going to make up here's another dictionary comprehension. Look, inside curly braces, we've got code and we've got dictionary-like syntax, key, colon, value. So now what we're going to get here is we're going to get names as keys and the size of the name as values, the number of characters in the name as values, because we're using the len function. It's kind of a weird thing to do, granted, but so this dictionary called dictpals here should have names as keys and the values will be how many characters are in the name. And where am I going to what names am I going to access? I'm going to access the list called pals up here. We're going to use this. So we're going to use a list to create the dictionary. And then we're just going to print that out. But then we're also going to try printing it out using a loop here. So let's see what we get when we run this. Here's the output that generates. Penny's name has 5 characters, which of course is true. There's our complete dictionary. And here's the result of running the loop here. Okay with that? Kind of a strange dictionary, perhaps, but as long as you use dictionary type syntax and some kind of a loop structure, you can create a dictionary with a dictionary comprehension. And finally, let's look at the last one here. The last part of this. Also, I'll uncomment this now. But maybe what I'll do is yeah, this one is going to use the dict pals. Once again, we have a comprehension here. Just widen this out a little bit so you can see the rest of it. So this time we're going to make a comprehension. There's that dictionary type syntax, K:\V, key: value, for KV in dictpals.items. So we're going to go through the dictpals dictionary using its items method, but we're only going to access, we've got an if clause in here. We're only going to choose names if the name is longer than 4, if the length of the name is more than 4. Remember, this value, this V here, is the length of the name in the dictpals dictionary. So we're only going to get longer named pals in this dictionary called long names. So we'll give it a run here. See what we get for the output. Yeah. There's the output I got. Oops. And as you can see, for the longer names, friends, they had to have more than 4 characters in their name, and that would be only Penny, Benny, and Valerie. Little bit complex. Dictionary comprehensions are tricky, and there's no doubt about it. But you can learn how to do them. Just takes a little bit of practice. So I'm going to send you that program in the chat right now. And that one was called Dix_5, I believe. Okay, I think you've got that one now. I believe that's the one that we just did. Yeah. Let's look at another example. Let's take a look at one that's maybe a little bit simpler. Let's take a look at this one about foods. We'll make a dictionary about food items here. And basically what we're doing here, we've got keys, and then this is the number of calories that are in each of these items. Okay, and by the way, I've just made up these values. So let's say bread has 120 calories in a slice, bagels are 200, banana 106, and so on. Okay, so key value, key is the food item, value is the number of calories. This will get rid of the bagel because there's too many calories in it. The DEL, that'll get rid of it. Now, if apple is not here, we can add it by using the not in, right? If apple's not in, and of course it isn't, then we'll add it with 65 calories for the apple. And then we'll get just the keys. Foods.keys, that should allow us to get just the keys. And then we'll loop through the keys. For F in my foods, print F. So that's just going to print the individual food item, which are the keys. And then we'll use the length function to report how many foods are in the dictionary. And then we'll use a loop to go through it. If we want to get a particular key's value, we could use the square bracket technique, which we've seen so far. And here's that get method, which we haven't actually used yet. So if you use foods.getEgg, that's another way that you can retrieve the value for a particular key. So let's give this one a run. Here's the output that generates. Notice pop item, the last line here, actually returns. This is a tuple. It's inside round parentheses, so that's how you know it's a tuple. But you'll notice that it does give you the information about the apple. And you can see that we did have apple was added, and we also saw that the bagel was deleted. There's no bagel listed here now. And there's the two ways to get a value. You can notice, of course, they would get the same value of 75 using the square bracket approach or using the get method. So that just shows you some of the methods that we see here on page 475. Now I've got a similar one to show you. And it's so similar that I don't think I'll even bother. I'll include it in the zip later, but it's very similar. So I won't bother with that one. But let's take a look at let's try this one. Here's another example that we made up for you here. Dictionary of hockey players with positions as keys and names as values. So this is pretty straightforward one. And this will be for the Tampa Bay Lightning, also known as the Bolts. And as you can see, we've got positions as the keys and player names as the values. And I've got some actual correct names for some of the Lightning players. And then we could, after creating this dictionary, notice I've got 6, so that shows a complete group that could be on the ice at any given time. And we're going to loop through it with a for loop. But we're then going to use the not in operator to see if point is on the ice. And as you can see, he's not here. We don't have point. So what we'll do is we'll substitute Stamkos for him. So let's see what happens here if we give this a run. Yeah. So we specified that the center is now going to be Braden Point. Number of bolts on the ice would be the len function. That's how many players we have using the len function. And then we use the items method to go through the dictionary. So nothing particularly new here. It's a rather simple dictionary because we only have single values for the actual values. It's a single string instead of a list, right? So I hope you're okay with that one. Let's take a look at another one here. How about let's try this one. let's create a dictionary from keyboard input, kind of like we did earlier. Got a lot of extra real estate down here, which I'll get rid of. Okay, so let's say we have a collection of antiques. Okay, we're collecting antiques. So we start off with an empty dictionary called antiques using our curly braces. And then we're assuming that we've got 5 antiques that we want to store in our dictionary. So we'll enter the item name and then the item price, which of course would be a float. And then we'll add that item to the dictionary. Antiques key item, the value will be the price. And then we'll go through just displaying the keys only. And then we'll show the keys and values. And then we'll also do the keys and values in another way using the items method. So this is kind of a basic one, but we're creating the dictionary from the keyboard in this one. So, and we have to enter 5 different items. So let's see that got an antique table. And I paid $250 for that. And I've got an antique cabinet. And I paid $300 for that. And I've got an antique bench, which was $125. And maybe I've got an antique dresser, which I paid $400 for. And finally, an antique bed. And this is true. I got it out of a junkyard. So its value is 0. Now, here's just the keys. Notice there's just the keys. Keys and values. Now here we're going through the dictionary, printing out the keys and the values. This time I didn't have $signs and I didn't format the currency very well, but that's from this first loop over here, right? This first for loop. And then we got a little bit better output following that, where we did actually specify using the items method. And then we did format the currency properly. Yeah, I found an antique brass bed in a junkyard, believe it or not. Okay. Let's try a couple more. And maybe what I'll do is I'll ask you to see if you can make one up, okay? So let's see if you could do it. And what we'll do is we'll ask you to, what we'll do is we'll start off, first of all, we'll start off with something and then I'll see if you can carry on with it. Okay, so what we'll do, we'll create a little program here. We'll call it challenge. This is going to be a challenge for you to try. And what we want you to do here is we want you to, we'll give you a dictionary to start with, and I'll put the dictionary in here. And this is going to be, we'll call it payroll. And we'll hard code the dictionary in. And we're going to put employee Benny. And Benny works 40 hours a week and his rate of pay is $15 an hour. And now I'm going to stack these up, which is commonly done, and it makes it quite readable. Notice what happens here when I press enter. Right there, it lines up, expecting that I'm going to enter another key, which I will do. So we'll go with Kenny, and let's say that I'll send this to you in a second, folks. And he works only 32 hours a week, but he makes $18 an hour. And then we'll go with Jenny. And Jenny works 40 hours and she's pretty sharp. She makes $21 an hour. And then we'll go with Lenny. And Lenny works 40 hours as well. And he makes $16.50 an hour. And finally, we'll put Penny in. And Penny, she's a supervisor. She works 40 hours and she makes $25 an hour. And that's the end of the dictionary. So we'll finish it with our closing curly brace. And I'd like to kind of line them up just so I can visually see that that lines up with the start curly brace there. So there's our dictionary. We've got 5 employees. We've got their names as keys. The values are the hours worked in a week plus the hourly pay rate. No comma after the last one, right? That would be an error. If you put in a comma here, that would cause an error because that's the final element in the dictionary. Now, what I would like you to try to do, and I'll give you a couple of minutes to do this, maybe 10 minutes we'll give you to do this. What I'd like you to do is process this dictionary and work out the weekly pay for each employee and print that out. So we want to print out Benny works 40 hours at $15 an hour. Pay is, and I guess it would be $600 for Benny. Okay, so we want to see if you can generate that output. I'll try to describe that up here in a triple quote. So we'll say process the payroll dictionary to calculate and print the weekly, the weekly pay for your employees. This is your company. Okay, so that's the objective. Okay, so what we want to do is we want to loop through that dictionary and work out the pay for each person. And maybe we'll add another feature. Also determine your total payroll. Thinking like you're the manager, okay? So you're going to add up all the pays for each employee. So you want to get the total payroll as well. So I've got 11:37. I'm going to give you 12 minutes to try that. Okay, 12 minutes. So it's now 11:38. So 11:50. At 11:50, we'll take this up. I'm going to pause recording right now, but I'm not going to go away, so you can ask me questions. We'll resume recording at 11:50. Okay, we're back. I hope you've had a chance to write this program. If anybody in the class that's currently present here, how would you start here? And there, by the way, there's a lot of ways that you could do this that are equally correct, right? But basically what we want to do here is we want to multiply the hourly rate times the hours to get the pay for each employee, right? And then we'll print that out. So,
And we have to assign that to the variable k. Well, to its own variable pay
yeah, pay,
and
pay,
hours.
pay equals, yeah, that would be good. Pay equals
And,
what?
K and square brackets. 1.
Okay, and then what?
We start a new line for hours.
I don't think we need this to calculate the pay. I don't think this is what we want. What
We
we
don't
want,
have.
we want to multiply these two values here.
Mm-hmm.
Now, this whole thing is the V in our items, right? This whole thing is the
Well,
V.
well, if we're going to do it that way, then I mean, we could. I Are we going to put in one on one line? Is that what you're trying
Yeah,
to do?
yeah. Let's multiply the values together right here. Yeah. What do we want to multiply?
Well, it would be we're multiplying k1 and k0.
I don't think it's K1. No, K is the
V1
that's right, is V1. So this, remember,
value.
this is your V. Your V is the list. K comma V. V is your values. In our case, the value is the list. So
V0 times V1.
outstanding. That's what it needs to be here. Yeah, V0 times V1. Now, like we did in that last, well, I guess it wasn't the very last one, but we could, if you want, we could add an extra line in here to make it maybe easier to follow. We could do something like hours equals V0, right? We could do that.
Yeah, that's what I was trying to.
Okay, and then okay, and then we could say rate equals V1, and then for the pay, we could simply put, of course, hours times rate, right? And maybe it's easier to follow that way. But the first value here, that's V0, and there's V1, the hourly rate. So if we multiply those together, that's our pay. So now we're ready to print something out, right? Well, actually, right now would be the logical place to accumulate the pay. So right now, I think we should do the accumulation total. And that's where you use plus equals. Total plus equals the pay. So that's the accumulation step right there. And then we could print out a line. Now, how we print that out, of course, could vary considerably and be equally correct, I think, because I didn't specify it. I didn't give you any sample output, but what do you say we start off with the employee name, and we could say, hey, you know what? This would be nice to do in a table. It'd be nice to generate this as a table with columns. First column being the player name, the employee name, the second column being the hours worked, the third column being the rate of pay, and the fourth column being the actual pay for the week. So we can do this very nicely with 4 columns. Why don't we do that? Why don't we start off by printing the name, which of course is our K, and why don't we put that in a column that's maybe 8 characters wide. So we'll go with K8, and then we'll follow that with the hours worked. That's now we could put V0, but since we've created the variable, why don't we use HRS, our variable name? And for that, we could put that in a column that's maybe, how about 5 with a width of 5. And then the rate of pay. So for the rate of pay, let's put that in a column that's, how about 7 characters wide, and that would be our rate variable. That column 7 characters wide, and we probably should format that with 2 decimal places. So that would be 0.2F, right? So it looks like currency. And then finally, we would get the actual pay, which is our pay variable. And we could put that in a column that's also 7 characters wide with 2 decimal places. So maybe something like that. Let's see what happens with that. Now, I guess we need one more line to print out the total pay, the total payroll, but that shouldn't be inside the loop. So we backspace once to print that. So we could then print, again, using an F string, total payroll is, and that would require a placeholder. And we're going to put our total variable there. And we'll format it with also with 2 decimal places. So let's go with this for starters. See what that turns out like. So here we go. Give it a run. See what happens here. I've called it challenge. Well, I'm not too happy with my column widths. As you can see, these 2 columns are too close together, definitely. So also in my payroll, since it's more than $1,000, I could use a comma right here. So there's a few things that we could fix up to make this program better. So I think what I'll do for the pay column, I'll maybe make it 10 characters wide instead of 7. I'll put a 10 here, and I'll put a comma right here for the total payroll so that I get 1,000. So I've added a comma here, and I change this to a 10. So let's see what happens if we run it again. That's not too bad. That's not too bad. Oh, I guess I could use a comma here too on that 1,000. So I could put a comma right there so that that shows up properly for anybody whose pay is over 1,000. And it's pretty much done, I guess. Although we could put column headings on each of these columns with a print before the loop started, right? So we could do that for sure. And the best way to get that to line up properly is actually just to copy this print. So if I can copy the whole line here, if you copy that entire line, having mouse issues here today. Just want to copy this line. So I'll copy that and put it before the loop starts. Otherwise, we would be printing it every time the loop cycles, which wouldn't make sense. So we'll put it here before the loop starts. And of course, instead of K here, what we're going to put is employee. So that's a string. So I'm going to put it inside double quotes. So I'll just put emp. And for the hours, that'll be a string as well. So we could put the hours variable or the hours string inside there. And rate is pretty good, but we need to put that inside quotes. And obviously the 0.2 wouldn't make any sense. We got to get rid of that. When we're working with a string, there's no decimal places, of course. And for the pay, we'll change this to be pay inside quotes. And we'll get rid of the decimal points for that. So let's see what that looks like. Give that a run. And see if it's an improvement. Hopefully it's an improvement. Not too happy with the way the hours and the rate worked out. See, by default, I didn't put any alignment indicators in here, right? I have no alignment indicators here, and I don't have any here either. So I guess to make this better, we need to put some alignment indicators in. So for the rate, I think for the hours, rate, and pay, I think I should use right alignment. What do you think? I think right alignment should work pretty well. So let's do that. We'll go with a right alignment with 7 shouldn't be too bad. And we'll also right align this one with a greater than sign. So that should cause right alignment. Let's see if that makes it a little bit better. Yeah, that's much better. That's much better. Okay, hope you're all right with that one. Now we could have centered if you'd rather, if you like centering better than aligning as we have done. You can do that too. But what this was really about was these steps right here. Being able to access the list to get the values to calculate the pay for each employee. That's the tricky part. Okay. Now, I've got one more example. It's a little bit after 12 here, so we don't have too much time left. Got another example that I wanted you to see, and I'll load it up for you. And of course, I'm going to share all these with you. But here it is. It's called employees, emps.py. It's kind of similar to the last one because we're going to work out payroll, but we're going to do it by reading a file. As you can see, we're going to read a file called employees.txt, and we do have that file. I'll just show you what's in that file. Here's what that file looks like. I've got employee names, how much they make, and how many hours they work. So it's a little bit different in that I've reversed the values of the hours and the rate of pay. But that's the file that we're going to read. So let's see what happens then if we run this program. What we're going to do is we're going to read the file and create a dictionary. And here's the line that creates the dictionary after reading the data out of the file, like we did in chapter 6. So we're going to create the dictionary, and then we'll process the dictionary to work out the pay. This time it's V0 times V1 again, but although I've got the rate before the hours in this particular dictionary. So when we run this, it runs kind of like the last one, except I don't have the total accumulator, no accumulator. It's just working out the pay for each employee. So I just wanted to show you that you can create a dictionary from a file. And finally, we've got a couple more that show you comprehensions, dictionary comprehensions. And this will be the last one. There's a few more in the zip file that I'm going to send you in my courses when I email you. But look what we've got here. I'm going to create a list comprehension, square brackets with code inside the square brackets. So what we're going to do is we're going to create some Celsius temperatures from -40 to +40 with increments of 10. So this will go from -40 to +40 and create a list called CEL for Celsius temperatures. Then let's make a dictionary with keys being the Celsius temperature. There's the colon. Notice there's the colon. So the key is going to be the Celsius temperature. The value is going to be the Fahrenheit temperature converted using the formula that converts Celsius to Fahrenheit. And we'll do that for every temperature that's in the CEL list. So for every C in the list up here, we'll create this comprehension. This is a dictionary comprehension, obviously. And then we'll try to print out a table showing the equivalent temperatures in Fahrenheit and Celsius. And here's the way that runs. -40 Celsius is also -40 Fahrenheit. 40 degrees Celsius is 104 Fahrenheit. I don't know if it's ever got that hot here. I don't recall that it has personally, but maybe it has. Maybe in the interior of Florida, it might get that hot now and then. Okay, so just wanted you to see that. It's kind of cool how you can make a comprehension, a dictionary comprehension from a list that you create with a list comprehension. Very, very powerful tools, these comprehensions. Well, thank you very much for that. And hang in there. I will be here next Monday. I will be here next Monday as usual, but let's just consider it a problem solving period where I'm going to help you maybe finish up with some of your assignments that you might be redoing, maybe even this assignment. And so I won't actually have, I guess I won't be recording. I guess what I'll do is just be, let's consider it office hours next week. Okay. We'll call it office hours from 9 o'clock until noon next week. So have a great week. Good luck with your assignment, and be careful out there because we got that new nasty Omicron virus coming around.